Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called The Greatest Line by Lear. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. On each line, there is exactly one cell whose value is greater than the sum of any other two cells on that line. Okay, so that means on this line, you have to have a cell that is only exactly one cell, which is greater than the sum of any other two cells on that line. And you'd have to have it for every line, which is interesting. So, for example, if this were, say, these were the low digits, you had, say, 2 and 5 here, then this digit would have to be 8 or 9, assuming these were the low digits. Because you only have exactly one digit, which must be greater than the sum of any two other cells on that line. This adds up to 7, so obviously 8 could be here also, and 9 could be here. And that's how these greatest lines work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. The long line is interesting. You have a guaranteed. Okay. So obviously, you cannot have 5 digits on the line. You can have at most 4 other smaller digits on the line total. Because if you have 5, that means you guaranteed have 1, 2, 3, 4, 5. And 4 and 5 add up to 9, which no digit is going to be greater than. So you have at most 4 unique digits on a line. And therefore, on this line, the largest digit has to be in box 1. Because, again, you can only have 4 unique digits on a line. And we have 5 cells on this line in row 1 and in column 1. Well, what does that mean? That means that the exact 1 digit then has to be in row 1, column 1. So this is the highest digit, which means the remaining digits in this box are all lower, or are on this line are all lower. Okay. That's the only one that really has that restriction. So these are the digits. It cannot contain both 4 and 5. It has to be 1, 2, 3 with either 4 or 5 here. So the remaining digits in this box then cannot be 1, 2, 3. It has to be, so this has to be 8 or 9. Because it can be greater than 7. This has to be 4 through 9 here. You have 3 other digits here. So remaining digits in row 1 are 4 through 9. Remaining digits in column 1 are 4 through 9. And remaining digits in box 2 are also 4 through 9. Okay. So where on this line can you ever have two that are two lowest digits? So non-greatest digits. And the answer is no. Because you're guaranteed only one of these is 4 or 5. The next highest has to be 6. So that does not work. So one of these is the high digit, so these must be low digits here. So one's low here, one's high. But we don't have necessarily the restrictions here that we do with this. Actually, we kind of do, don't we? Not necessarily. Well, yes, necessarily. Okay. These digits, you're guaranteed at least a 4 or 5 here. So you cannot have another 4 or 5 here. So this must be 1, 2, and 3 at most. To add up with the 4 or 5 here. Because if you can't have 4 and 5, if you have 4 or 5 here, that would add up with 4 or 5 to add up to 9, and no digit is going to be greater than 9. So this is guaranteed to be 1, 2, 3. And this has to be then the other 4 or 5. So this is guaranteed to have the 4 or 5 here. Which means it cannot be here, which means this is... So this is 1, 2, 3. So this has to have the other 4 or 5 here. With the 1, 2, 3. So then this must be 1, 2, 3 only. This is 1, 2, 3 with 4, 5. But we don't know which one. This could, though, be 6 here. 6, 1, 2 does work. So these two digits are the same as these two. These two digits are the same as these two. So these two digits are the same as these two. Interesting. We have 5 digits here. So we know these two digits are these two digits, and they must be 2 out of those 3 digits there. So this could be, you could have the high digit, the greatest digit in any of these spells, because we only have 4 unique digits there. Okay, so I don't know how we mark these. Let's mark these as green. They must be the same as these, which are green. Or maybe we just mark these as blue, and then we mark the other ones as green. Yeah, that might be better. So these are green. These are the same. These are the same. We know blue has to be 2 out of those 3 at least. Well, it has to be exactly 2 out of those 3. We don't know. So one of these is a high digit here. We're not sure which. You could have 7 here as the high digit. That could work. Um, hmm. What are the restrictions for 4-length lines? Or 4 unique digit lines? Um, the smallest digit, sorry, the largest smallest digit has to be 6. The largest digit can be 7 through 9. Okay. That's pretty much it. You don't have to have a guaranteed 1, right? You could have 2, 3, and 4. Oh, wait. Any other 2 cells on that line. This has to be 1 through 5, 1 through 4 here. Because 4 and 4 add up to 8. Okay. So this is 1 through 4 here, which means none of these could be 4. We have to have 9 here to be greater than 8, which 4 and 4 add up to. So no 4 or 9 here, no 9 here. Okay, so that helps a lot. So we can remove 4 and 9 here. This then can never be 6. Actually, it couldn't. Well, okay, hold up. Right, it can't be 6. If we try to have 6 as a high digit, 1 and 5 is already 6, so that doesn't work. If we have tried to have 6 as a low digit, 6 and 2 add up to 8, which is too large. So first of all, we're guaranteed 5 has to be one of these. And it must be 5 with 1 and 2, because 5 and 2 add up to 7, and only 8 is greater. So this is 5, 8 as a pair, which eliminates 5, 8 in the rest of the box. This is 6, 7. So this must be 1, 2 as a pair, which eliminates 1, 2 in the rest of the box. So this is 3, 4, which means this is 3, 4, which means this is 3, 4. No 3, 4 here. It's 1, 2. Right. Because 8 is greater than 5, 2 and 5, 1. And obviously 1, 2. So remaining digits in column 2 are 3, 4, 6, 7, and 9. We know we have 1 and 2 somewhere here. This can't be 3, 4 because of the 3, 4 pair in the box. Remaining digits in this box are 5 through 9. This can't be 6, 7. So remaining digits in column 3 are 1, 2, 3, 4. 5. This can't be 6. How did it? Okay, so this is 5, 8, 9, which eliminates 5 and 8 and 9 in the rest of the box. This is 6, 7 as a pair. One of these is 3 or 4. These are all 1, 2, 3, 4. And I don't think they can ever be a high digit. If this, well, you could have 5, 3. That possibly works. Hmm. 4 eliminates 4 in the rest of the box. Remaining digits of column 5, we have 1, 2, 5 through 9. No 6, 7 here because of a 6, 7 pair in the row. This can't be 6, 7. So we have 1, 2, 3, 4, 5, 8, and 9. Okay. 4 can never be a high digit in a 5-length line. Because even then you're going to have 1, 2, and 1. Well, this digit's higher for one thing. Um, um, hmm. Okay. Hmm. Remaining digits of row 6 are 1, 2, 3, 4, 5, 8, 9. So that's not helpful. Uh, hmm. Hmm. Can this ever be 6 as a high digit? I think the answer to that is no, right? If this is 6 as a high digit, we are guaranteed a 5 here at least. And 5 and at least 2 is going to add up to 7. So no, 6 can't be a high digit. 6 could be a low digit, though. 6 with 1 and 2 could add up to 8. And then this would be 1 and 2. And that does work. Can 7 be a high digit? The answer is no. Because you have 5 and 2, again, adding up to 7 at least. And can 7 be a low digit, though? The answer is no, because 7 plus 2 adds up to 9 at least, and 9 cannot be greater than 9. So you cannot have a 7 here. But you could have a 6 there. Can you have 8 as a high digit? Yes, because you could have 1, 2, and 3, or 1, 2, and 4, or 1, 3, and 4, or 2, 3, and 4, all here. That is potentially possible. Can you have 5 as a low digit? You could. Huh. Okay. Interesting. Okay, you cannot have high digits here. If you have... Oh, actually, no. Okay, you cannot have repeat 5s. So you cannot have high digits here, or the greatest digit here. If you did, this is at minimum 5. These would be 4 digits, which are not high digits. So you would guarantee at least have a 4 or another 5 there, which adds up to 9 or 10 with this 5. So this cannot be high. It has to be low here. Um, this could potentially be the high, or you could have a high on this line. So this can never be... This is the same... This can never be low. No, this can never be high also, right? If this is high, that means you have 4 digits... Well, no, that's not true. It's just that these can never be 5 through 9, I think. And the reason why you know that is either this is 5, and so if we try to have 5 through, or a low 5 through 9 here, or above, if you have a 5, that would mean this is, and this is the high digit. That means one of these digits is 4 or 5, which adds up with 5 to add up to 9 or 10, which is greater than that digit could be. If this is not the high digit, it's a low digit, or not the greatest digit. It's basically a lower digit, which would mean 5 and 5 at minimum, adding up to 10. So this cannot be 5 through 9 here. It's 1 or 2. This can't be 5 or 9. It's 1 through 4 here. We have 1, 2, 1, 2 in column 5, which eliminates 1, 2 in the rest of the column. And then we have the same problem here, because these, even if these were the same digit, that would be 5 and 5 at least at most. So one of these is a high, therefore this is low. We have low here. One of these, so these must add, that doesn't work. It would have to be 5, 1, 2, and 1, 2. But that would eliminate all possibilities for that cell. Ooh, that's bad. That's really bad. Huh. Because it cannot be 1 and 2. One of these has to be 3. And all of these cells see these cells. Ooh. Shoot. How does that work then? Three and 5 add up to... Oh, 3 and 5 add up to 8, so that works. Okay, never mind. Never mind. So one of these is 5, the other one is 9. So that works. So then this is 1, 2, 3. So 3 and 5 add up to 8. So this has to be 5, 9 as a pair. 3 eliminates 3 here, so this is 4. That's 3. So we can remove the coloring, actually. Well, I guess we'll just make it all blue. This 3 means this can't be 3 here. Remaining digits in this row are 5 through 9. So one of these two is the high. That means these are all low. You cannot have 5, 8, or 9 here. So this cannot be. One of these is a 5. So you cannot have a 4 with it. So none of these are 4. So we have a 1, 2, 3 triplet in box 5, which eliminates 1, 2, 3 in the rest of the box. This is 1, 2, 3, 1, 2, 3. This must be 5 and 9, which eliminates 5 and 9 in the rest of the boxes they're in, or rows they're in. And this can't be 5 or 9, it's 8. There's no 5, 9 here. This can't be 8, 6, 7 as a pair. This can't be 1, 2, or 3. So we have 1, 2, 3, 5, and 9. We don't know which one's high here. This 5, 9 pair eliminates 5 and 9 here, so that's 8, which makes that 5. So this is the high digit. This is obviously lower than that. We don't know which one of these fits there. 8 eliminates 8 here. You cannot have a 6 anymore here. Because if you have a 6 here, this is guaranteed to be at least 4 here. And 6 could only be a low digit. 6 can't be a high digit. So this can't be 6 anymore. This is 5 through 9. That's interesting. Remaining digits in box 5 are 4 through 9. 3 eliminates 3 from being here. We have a 1, 2 pair in the row, so the remaining digits in that row are 4 through 9. Interesting. No 6 or 7 here. Four through 9 remains in column 6. 4 through 9 remains in column 7. That's interesting. Okay. 5 can no longer be here. Remaining digits in row 3. We can have 1, 2, 3, 4, 6, 7. Okay. Well, one of these is guaranteed to be 6 or 7. This is 5, 6, 7, and 8. So that eliminates 5, 6, 7, 8 in the rest of the box. So this is guaranteed to be 6 or 7 here. So we have a 6, 7, 8 triplet in row 2, which eliminates 6, 7, 8 in the rest of the row. So we have 1, 2, 3, 4, and 9 left. Okay. Can this ever be 8? I think the answer is no. Oh, these 5, 9 both see 5, 9 here. So this cannot be 5 and 9. If this were 8, can this work here? This would be guaranteed 5, and we have at least 1, 2, 3 here. And 3 and 5 at least add up to 8, which is, this is not greater than. So can it be the lowest digit? No. 8 and 2 add up to 10, which is going to be greater. So this cannot be 8. This is 4, which eliminates 4 in the rest of the box and the rest of the row. 4 and 5 doesn't work because 5 is not going to be greater than 4 and 1. And 4 and 5 add up to 9, which no other digit is going to be greater than. So this must be 9 here, which makes this 5 here, which means this can't be 5. This can't be 5 or 9 because it sees 2 different 5 and 9s here. No 5 here. 9 is here, which eliminates 9 in the rest of the row. This cannot be 9 here, so we have guaranteed 1, 2, 3, 4 in the rest of box 7, which eliminates 1, 2, 3, 4 in the rest of the box. This is low. This is a high. This is obviously low. We have 6, 7, or 9 here. So can this ever... So this is one of these two is guaranteed to be high. Because we can't have both of them be low, because 5 and 6 add up to 11 already. So this is guaranteed low. And this cannot be low, because if this were low, 6 plus 2... Well, no, it could be 6 plus 2, adding up to 9. So that could work. We cannot have 4 here, because 4 in this region would add up with 5 at least. So that means that's 4 and 5 would add up to 9, which is greater than a digit can be. So this is 1, 2, 3. We have a 1, 2, 3 triplet in column 4, which eliminates 1, 2, 3 in the rest of the column. This is then 5 through 9. Okay. If this is 6, then this must be 9. If this is the high, then this has to be 5 or 6, which would force this also to be 9, because 5 and 2 add up to at least 7. And this can't be greater. So one of these is 9, which eliminates 9 in the rest of the row. So there's no 9 here. So again, if this is 6 and low, it's 1 and 2 here at minimum. 6 and 2 add up to 8. 9 has to be greater than 8. So that must be 9. If this is the high digit, then this is at least 5. 5 and 2 add up to 7, which 6 and 7 are not greater than, so that would have to be 9. Okay. One of these is a high digit, which means this is a low digit. This cannot be 4 or 5 or above because one of these is guaranteed to be 4 or 5. So this must be 1, 2, or 3, which eliminates 1, 2, 3 in the rest of row 9 because we have a 1, 2, 3 triplet. So this is 4 through 9. 6 or 7 cannot be the high. Well, it could be. Never mind. You could have 4 here. But one of these two must be the high. Because you can't have 4 and 6 as lows here. That adds up to 10, which no digit's greater than. So one of these is high. These must be low. So this cannot have 5 here, because 5 and 4 at minimum add up to... So we have 1, 2, 3 as a triplet in row 6, which eliminates 1, 2, 3 in the rest of the row. This is also 1, 2, or 3. Because, again, 4 with 6 would add up to... 4 with 8 or 9 add up to too much. 4 with 6 add up to 10. So again, this is 1 through 3. We have a 1, 2, 3 triplet in row 7, which eliminates 1, 2, 3 in the rest of the row. This can't be 1, 2, or 3. It's 4, which makes this 3. This can't be 3 or 4. There's no 3 here. So 4 eliminates 4 here. So the remaining digits in the column, in the row, are 5 through 9. 1, 2, 3 here. Okay. 6 and 2 would force this to be 9 here. So this can never be 8. 4 and 2. So for this line to work, either this is 4 as a low, which would make this at least 1 and 2, which would force this to be 7. And this would have to be 1 and 2. Or this is 6 as a low, and 1 and 2 minimum add up to 8, which 9 could only beat. So either way, this is going to be 1 and 2, which means this can't be 1. We have a 1, 2, 1, 2 pair in column 9 and in box 6. So this can't be 1 or 2, it's 3. That means this can't be 3. No 1 or 2 here, no 1 or 2 here. This is 3 here. This still could be 2 lows. Can this be high? 3 and 5. Yeah, actually could. Remaining digits of row 9 cannot be 1, 2, or 3 here, so this is 4 through 9. Where is the 3 in row 7? It has to be here. So this is 3, which means this can't be 3 here. Which means where's 3 in row 4? It must be here. So this is 3. That means this can no longer be 3. Where is the 3 in row 9? It must be here. So this is 3. We cannot have 6 here as the low, because 3 and 6 is already adding up to 9. And if we try to have 5 here, 3 and 5 as a low, 9 would have to be here, but but that would eliminate all possibilities for this cell. So this cannot be 3 and 5 as a low. It must be 3 and 4 as the low. And therefore, 4 would eliminate 4 here. So this is 9, which makes this 5, which makes this 9, which makes that 5, which makes that 9. And this can no longer be 9. What digit's greater than 3 plus 4? It's 8. So this is 4, 8 as a pair. This can't be 5, 8, and 9. No 5, 8. This is 6, 7 as a pair, which eliminates 6, 7 in the row 1. So this is the high digit. This is high digit. This is low, low. We have 3 and 5 at most here, which adds up to 8. 3 and 5 at most here, which adds up to 8. 3 and 4 add up to 7, which 8 is greater than. 4 and 8 are eliminated from the rest of the box. So that leaves this as 1, 2 here. 3 eliminates 3 in the rest of the column. 9 eliminates 9 in the rest of the box. So these are smaller than this, so these have to be low, which makes this a high. Okay. This can't be 9 because one of these two is a 9 here. 9 eliminates 9 from being here or here. So that means where is the 9 in this line? It has to be here. So this is 9, which means this can't be 9 here. That means this is 2 and 5 or 2 and 6 at most, adding up to 8. Okay. We have a 5, 8, 5, 8 pair in column 8, which eliminates 5 and 8 in the rest of the column. Actually, 5 eliminates 5 here, so this is 8, which makes this 5. So this must be less than 5, which makes this 1 and 3. 5 eliminates 5 here, so it's 8. No more 1 here. This is 2, which makes this 1. 2 eliminates 2 here, so it's 1 and 2. 1 eliminates 1 here, so it's 2 and 1, which eliminates 1 here, so it's 2 and 1. Which eliminates 1 here, so it's 2 and 1. Which eliminates 1 here, so that's 2, that's 1. Which eliminates 1 here, so it's 2 and 1. It also eliminated 1 here, so that's 2 and 1. That's pretty cool. 3 eliminates 3 here, so it's 4 and 3. There's no more 3 here. No more 1, 2 here. 4 eliminates 4 here, so that's 3 and 4. 8 eliminates 8 here, so this is 5. This cannot be 9 because of 9 in the box. There's no 5 here because of 5 in the column. No 5 here, so this is 6. So this is 1, 2, it's 2 and 6, adds up to 8 at most, which 9 is greater than. That eliminates 6 from the rest of the box and column. This can't be 5 because of 5 in the column. We have a 7, 8, 9 triplet in box 8, which eliminates 7, 8, 9 in the rest of the box. So this can't be 7, 8, or 9. It's 4, 5 as a pair. 6 eliminates 6 in the rest of the row. Okay. 5 eliminates 5 here. That means one of these two is 5. Where's 5 in row 7? It has to be here, so this is 5, which eliminates 5 in the rest of the box. Okay, so again, let's check. 4 and 4 at most adds up to 8, which 9 is greater than. 5 and 2 at most is 7, which 8 is greater than. 5 and 3 at most adds up to 8, which 9 is greater than. 4 and 4 at most is 8, which 9 is greater than. 2 and 6 at most is 8, which 9 is greater than. 5 and 3 at most is 8, which 9 is greater than. 1 and 3 at most is 4, which 5 is greater than. where we have a 6, 7, 6, 7 pair in row 7, which eliminates 6, 7 in the rest of the row. This can't be 6 or 7. It's 9, which means this can't be 7 or 9. It's 8, which means this can't be 8. It's 7, which makes that 9. 7 eliminates 7 here, so that's 8, which eliminates 8 here. This can't be 8 either. Where is the 8 in box 2? It must be here. 9 cannot be here anymore. Where is the 9? 9 eliminates 9 here. So this is 4, which makes this 9. Therefore, this must be 2 and 6 to add up to 8, because 7 doesn't work. So this is 6, that's 7. 4 and 7 eliminate 4 and 7 here, so it's 6, which makes this 7, makes that 4. No 6 here. This is 5, 7 as a 7 eliminates 7 here, so that's 6, which makes this 7, which makes that 6, which makes that 7. 7 eliminates 7 here, so that's 6 and 7, which eliminates 7 here, so it's 6 and 7. 7 eliminates 7 here, so that's 6 and 7. 7 eliminates 7 here, so that's 8, which makes that 6. 8 eliminates 8 here, so it's 4 and 8, which means this is the low, and 8 adds up to 8, which is greater than 3 and 4 added together. This is 5. Oops. This can't be 1. It's 2. This must be 5. That's 4. 5 eliminates 5 here, so it's 7 and 5. And that's a solution. Yeah, it's pretty interesting. I was curious about how this rule set would work. It is pretty restricting, so I don't know how often we'll see this rule set. I was just curious how this would work. And there are a lot of restrictions on it once you start thinking about it. So it's an interesting rule set there. Maybe we'll see some more puzzles of it, though. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.